as we have members from all over the world. So thank you for your patience. In just 1 minute, we can start. So welcome to this Fluitec webinar. My name is Jo Ameye, and we are very pleased to have this amazing group of people gathered digitally. We have, as I see here now, a large group of attendees out of at least 6 continents, and I believe more than 30 countries. So thank you very much for attending, and let me first of all thank you for your time and interest in this seminar. We know that all the challenges you and us we are faced with today, we trust that you are all doing well, mostly staying healthy and inspired during these uncertain times. But like we say, to keep you motivated and educated, so we have launched today this digital platform of a training session, a webinar. And I would also like to just from a practical viewpoint say that you can answer your questions, just launch your questions. We have 2 moderators, my colleague Filippo Colucci and my colleague Clive McArdle. So they're gonna read the questions to me, and then I will be able to answer your questions during the presentation. So
yeah. Welcome everybody. Thank you very much.
Yes, thank you, Filippo. And good. This is for us the webinar with the title "Reducing Bearing Temperatures Without Shutting Down." I must say that over the last 3-4 years, this has been a topic that came up in several technical meetings, customer meetings, group meetings, and been highlighted to us as a very high important subject. With this webinar, we will try to give you solutions that are available today. And of course, we will first have a look at what is now impacting the bearings behavior and the typical issue of varnish deposits. Secondly, we will help you understanding what we typically see as temperature excursions on bearings. Where is this coming from? And then, like I told you in case 3, we will then help you to manage these temperature excursions by being online with your rotating equipment. And of course, as you will be certainly interested, we will go over different case studies. So when we talk about varnish, I can assume normally when in a room I ask people to put up their hand and tell me if they've ever heard about varnish. So in this case, I suppose that when you have decided to attend this webinar, that you already understand or have heard about the word varnish. So first of all, we want to give you a little introduction on what is now the varnish coming from, and at Fluitec we have more than 20 years being involved heavily with varnish. And one big mistake you can take is that you try to generalize varnish. It's certainly not the case, and not all varnish is identical. So it's very important, depending from the operating conditions of the equipment, rotating equipment, continuous base load, 24 and 24 hours, gas turbine, steam turbine, compressors. It's secondly very important, depending from the formulation of the oil, the base oil, the type of additives. And last but not least, I think very important, which influence the oil degradation pathways, is the type of contaminants. And so, yes, we can say that varnish is an oil-derived deposit. And then, of course, I would say helping us to understand the degradation. Over the 20 years that we have now been involved, and certainly over different research programs and more than 100,000 oil samples data we have at Fluitec, in combination with field data, we can categorize the degradation of lubricants in 4 categories. The categories: oxidation, that is the category where you have presence of oxygen, it's a slow reaction. You have the thermal degradation process, that's the degradation process in absence of oxygen, typical spark discharge, micro-dieseling hotspots. And the last 2 categories, which we will today talk about in more detail, is the presence of contamination, either external contamination. We think about, in this case, when we talk about rotating compressors, we talk about gas, process gases, as well the incompatibility as being key influences, I would say negative influences, during the formation of degradation products, better known as varnish. And as we speak about gas compressors as part of rotating equipment, it's clear that we need to realize what type of gases are used and how we can categorize them. Because, let me say, not all gases are inert. We see on the left side what we call inert gases. We have on the right side, the more reactive gases. Typically, some of you will recognize products like H2S, hydrogen sulfide, or nitrogen oxides. But having said that, even with carbon dioxide or ammonia being inert, they can also react, and being reactive, for example, a carbon dioxide reacts with water, will make some acids. And ammonia is known that it can also react with corrosion inhibitors or antioxidants and also make deposits. And add to that in systems where you have seal oils, they can also get contaminated with these gases and then be mixed with the lube oil reservoir. It's clear that compatibility is a growing concern, and not only between new oil types, that new oil is new oil, and therefore there exists an ASTM standard, D7155, as a practice on compatibility testing, but also it's a compatibility issue between new oil and used oil. Think about remaining products or remaining oxidation, degradation products, which are then coming in contact with the new oil, where then you can see first signs of incompatibility in the mixtures, such as air release or water separation characteristics, which can certainly have their impact. So oil analysis here and compatibility testing is absolutely key, and we are not extending much on oil analysis in this webinar, because that would be a webinar absolutely on its own. Now, this is what we call often the varnish family picture. And we have here a nice album of pictures. Absolutely, at Fluitec, we have a database of many thousands of these pictures. From, as you can see here, from all parts that you can imagine of a rotating equipment, valves, coolers, gearboxes, filters, elements, bearings, all kind of components, part of the rotating equipment. But what do we recognize here? And I'm sure some of you will recognize these deposits. If we look at what ASTM is using as a definition of varnish, they say it's a thin, hard, oil-insoluble deposit with composition primarily organic residues, mostly definable by a color intensity. Like you see here, you see some dark brown to light brown, more black. Very important is that it's not easily removed by wiping with a wiping material. You cannot remove it, and it's resistant to saturated solvents. You will notice also clearly varying colors with green, blue, orange. So that is in large contrast to some of the sludge deposits that you can find. That's a way of recognizing, categorizing varnish versus sludge. Understanding how varnish behaves is clear that we need to understand also the drivers. And one of the drivers, the physical chemical driver, is temperature. In this video, we want to show you when an oil is cold and you take a sample. In this case, you see the oil is less than 30 degrees C. You see the oil is hazy. This is typically caused by the presence of agglomerated varnish deposits. If we start then in this case to heat up the oil and we slowly heat it up, you will see the temperature indicator and showing the temperature increases. Just notice between just above 50 degrees C what's going to happen. You will see that your oil is now totally clear. That is the typical example of how varnish, which is first being insoluble, becomes soluble by playing on the temperature. Realizing that your oil on a rotating equipment is mostly above 50 and even higher than that. So the majority of your oil will then be, of your varnish will of course then be totally in solution. And we also often we compare it with the right here. Compare it with a cup of coffee. If you have the colder the coffee, you could say the oil, the lower the solubility. If you have a very cold oil, maybe 1 spoon of sugar. If your oil is warmer, and you can dissolve more sugar. And that is, I think, for you important to understand that the varnish is in different configurations, and the varnish which is totally soluble is usually the most harm, is causing the most problems because you can't see it. So that brings us to the next slide, and for us, the rule number one on this webinar is the nexus, the connection that exists between mechanical and chemical changes. I would say that if you look at a typical mechanical signal or a mechanical problem, we can talk about wear, but also think about maybe just vibration. You have usually mechanical engineers, they use also vibration analysis. The question we can ask ourselves is maybe the mechanical change preceded by a chemical change? And yes, I think that is typical what we have seen in this area of bearing temperature behavior, excursions or increases or wear, is that when we look at oil analysis, that we see that some changes already occur prematurely before you already can see any mechanical change. So oil analysis is again here coming up as an important tool to help you see this change and detect the trend of a possible change in the condition of the oil. That can, of course, be very helpful for rotating equipment, just as defined by your OEM specifications or ASTM standards focused on in-service oil analysis. Talking about the mechanical changes in relationship to the chemical changes, let's have a more detailed understanding of what could impact these two phenomena that we see today. So the first phenomena that we can clearly explain is an increased amount of wear. The second one is we will cover is the temperature graphs or behavior excursions that we are going to discuss. So the first part is really it's the amount of wear that is created in the bearing surfaces. If you are creating deposits by the varnish, knowing that varnish is very polar, the polarity of the varnish is making it it's very easily attracted to white metal surfaces. And I would say that's even accelerated by increasing load factors on your bearings. Now, due to disruption of this hydrodynamic film, you are seeing an inconsistent oil wedge, which is then creating also what we say here, a metal-to-metal contact. Knowing that, of course, the varnish is also very sticky. It's like because of the constituents that is made in the varnish are making the varnish like attractive for dirt and wear metals, creating a sandpaper-like surface. This is not. This is already for since mid of 90s that Dr. Sasaki published this effect of sanding paper. But the most important, of course, is that the disruption of this hydrodynamic oil film and resulting in inconsistent oil flow patterns, and then, of course, and creating this metal-to-metal contact. We have here a few examples of this pictures where we show you the evidence of varnish and creating a wear rate. On the upper left picture, you can see a very good example of that with, again, this typical wear that is occurring. Notice also that the varnish has also a different type of color. Where you have the highest load factors, of course, and that we will discuss later, is that where the load factors are higher, you will not have enough cooling anymore of your lubricant, and you will have the varnish will start to coquify, and that is typical. The reaction that operators have is that they believe that the oil is burnt, and that is a mistake. It's not your oil is burnt, it is the varnish as a polar product who starts to become coquified, and the black components is only the carbon who is remaining. We have more examples of this where you can see typical wear symptoms occurring on these different pictures. I'll let you look at some of the typical pictures we have here. Also here, another 4 or 5 good examples. Look at the one on the right upper. Also, you will see again the typical wear happening on these components. And like I told you, we have plenty of pictures. Notice again this amber orange color can be in different ratings present, can be very light present until, like you can see on the picture right down, the black coke deposits on these bearings. Here also on these thrust bearings in the middle, you can see how we have a metallurgic effect taking place, or really damage. That's why often when the varnish is removed, then you can see under the varnish already a metallurgic damage occurring. Don't forget that what we will discuss later is that when you don't have this hydrodynamic oil layer, that you will have absolutely wet and because due to metal-to-metal contacts. Another few sets of truss bearings were on the picture below on right, left down picture. You see also these stripes typical happening from second typical phenomena that we have been informed by being in the field is that customers or end users asking us and reporting abnormal temperature increases on their bearings. Typical on gas compressors, industrial gas compressors, and we have been digging into a little bit deeper and trying to understand what is really causing this. And absolutely, then if we talk about temperature increases, first thing you think about is there must be effect of lack of cooling. And as we all know, the number one function of lubricant is cooling, beside other functions, but cooling, dissipating the heat is number one. So knowing that varnish has a polar character, resulting in this metal attraction, and the lubricant will be compromised, and especially its cooling capacity will be compromised of the lubricant, resulting in the slightly slow increase of temperature. Um, and we see a typical increase by temperature in a sawtooth graph. We will try to explain you that how that works. We have here an example of varnish derived temperature excursions. What do we recognize when we start on the left side? You can see the small peaks starting to become larger and larger. And you will see that by being around the 3/4 of the graph, that suddenly the curve starts to be exponential. So there's a hysteresis occurring um, on this 500-day trend. And so progressively, you see that the temperature spikes are becoming more extreme. And how can we explain that? Well, let's clearly, we have here on the left graph, you can see again, one bearing temperature spike. As I want to repeat this is typical caused by an increase of the varnish layer, which is growing. Remember that the varnish is like a polymer, it's an oligomer, and through polycondensation, these varnish layers become thicker and thicker. It attracts one varnish to another varnish. On the red line is you can see is the bearing temperature spike. Interestingly enough, when we correlate with this bearing temperature, also the rotor position, you can see that it is also moving slightly away from its center. And if we want to then visualize it in a better way, is that here we have on the upper side, we have the rotor position, and we will try to then show you the bearing temperature correlation. The brown is the oil film, the dark brown is the varnish, and there you have your bearing. So imagine that you have now your layer of varnish, which is slowly increasing, and because it's a normal oligomerization process. Immediately you can see that already the bearing temperature is increasing. The oil is not able to dissipate the heat efficiently, and the layer becomes thicker, and temperature is again increasing. Mention also the rotor position, which is moving and constantly increasing, and that's this typical spike that you see, the increase of the temperature. And then suddenly, when the force to move the shaft becomes greater than the film strength of the deposit, it's like a wiping off effect on the varnish layer, and the temperature spike goes down. In some cases, spike goes down totally to its original temperature. In other cases, it has a hysteresis, and that's really large depending from the quantity of degradation products and also the typical, I would say, degradation products, if they're more poor or not. But typically, this peak will then come back, and you will see that the oil is then again with a small layer bringing back a normal temperature on the bearing and a normal rotor position. Now, the question is, how do we manage now these bearing temperatures? Imagine you have done oil analysis, you notice an increase of an MPC, you've noticed this bearing temperature spikes, you've seen more vibration. There are solutions for this, absolutely. Two solutions we want to bring to you is, first of all, is cleaning your oil. It's quite logic. We talk about the varnish deposits. It may sound logic, but it's not that very logic today in the market. There's still the mentality to just change the oil, which will not solve your problem, because your problems, as you've seen, your varnish deposits are sticking to your metal surface. You will not remove them. So at Fluitec, based on all this research we have been doing and in the field, is that we have developed a unique advanced varnish mitigation technology who is able to keep the oil clean. By doing this, it's clear that when the oil is clean, as the varnish deposit process is a reversible process, you're able to bring back the varnish into solution. And that is now what we have been finding out and experiencing over, like you say, many hundreds successful ESP systems onto the market. And remember, for your confirmation, that this technology, mitigation technology, works on the warm in-service oil. So no need to cool it down or give it additional stress. It is using the in-service oil, keeping it clean, and by treating it in bypass or kidney loop of your oil reservoir. The resins or technology is customized in function also of the type of oil, the type of varnish, and the type of formulation. So please consult us. We will help you in selecting the right media mix. Once the oil assist is clear and is clean, you're able then to keep the system clean. In some cases, this is still too slow. And that is where, since 2010, we have been looking at what can we do to reduce this bearing temperature spikes in a faster way. And even if the oil is clean, we see that the spikes are reduced. But can we accelerate that? Yes. Therefore, we have been going back to the essence of the issue today of varnish, and one of the main drivers is solvency, the solubility, if you want. So this is where we will present you technology which is working on increasing solubility or solvency enhancement as a unique technology today present at Fluitec. What does that mean for you? Because I'm sure that this must be for you very new for some of you, is that solubility is a driver, a successful and efficient driver to remove lube oil deposits. As an oil has a natural ability to dissolve products, we can work on that solubility. And it's clear that oils from generations group 1, which have a higher solubility because they have less, I would say, hydrotreatment, being hydrotreated. The group 2 and group 3 oils, they have a lower solubility. And that means that when you have a lower solubility, you will have like a balance between deposits into your oil and into the system. This is what's called the Chatelier principle. Therefore, we have launched and we bring this solvency, solvencer technology, so that it can increase the solubility and helping to bring the layers of varnish that you have formed layer by layer. Imagine, we receive very often that question, is the varnish now happening in 1 or 2 weeks? No, it's mostly a ongoing process, and it's layer by layer we have formed this varnish. We will do the opposite with the bringing the solvency, we will then again remove layer by layer and no sudden dump of contamination. Again, this is soluble varnish. It's not a hard particle, it's a soft particle. And these boost chemistry and to boost up your solubility and solvency is, as you can imagine, 100% compatible with your in-service lubricant, has also been approved by and been tested by all the major OEMs, equipment OEMs. And the lubrication system is then decontaminated in a few weeks to a few months, affecting clearly the bearing temperature spikes. We will show you later some case studies. And this brings, of course, then the mechanical issues reduces to a minimum. Additional advantage of this is that you have no flushing or no downtime, no risk at all for your lubricant because of compatibility. And just look at this solubility as a bucket. Normally it's affected by temperature. The lower the temperature, the smaller the bucket. Or we can also use an ESP technology, which is then slowly bringing back the reversible amount of varnish. But the solvency effect is going much more efficient and can offer a much larger oil bucket, a varnish bucket here, as you can see on this drawing, and where you can see that the metal is then becoming totally varnish free. So solubility as a driver is here clearly an additional way of saving these mechanical issues and avoiding further mechanical problems such as wear or temperature spikes. Even sticking valves, don't forget that also you could have a valves, your oil, which is a regulating oil for your valves, can also stick metals. We have a few minutes here, 5 more minutes left for showing you some case studies where we will first of all show you field case studies between what I informed you about the vibration. Is there a relationship between vibration and temperature on the bearings? The impact of not flushing. Remember that category 4 of oil degradation pathways is incompatibility. That means that if you don't flush, typically in industry, things have to go fast and oil changes are done fast and flushing is then not executed correctly. We will show you how you can do that. And then controlling bearing temperatures on typical how we have been able to control in different case studies in a refinery. Very first interesting case study is an offshore gas platform with gas turbines, where we noticed interesting behavior between, again, you will recognize the red lines or the spikes of the temperatures on this bearing. And within the time, you can see that these spikes becoming higher and higher until that even the gas turbine has to go out of service. We see that also then in the blue line. First one is vibration, slight effect of vibration, but on bearing 2, which is more rigid bearing apparently, is clearly there reacting, and you can see that the amount of vibration signals is clearly increasing. On this site, we have now intervened and we are cleaning the oil with successful results to bring down the bearing temperatures as well as vibration. So look at this relationship. Can be interesting also with gears, where often the gear is then also the gear bearings are then suddenly seeing an impact, increase of vibration. Another good interesting case study is what I was informing you is that when you don't attach enough importance to flushing strategies and you change oils without looking at the impact that remaining oxidation, degradation particles can do when coming in contact with the new oil. This is a case study where on the left side you can see here is a point where they change the oil. And within, as you can see, within 1 or 2 days, this is, as you can see on the X, it is 4 days, within 4 days, you can see that on the low, medium, high pressure side of this compressor, that all the temperatures are increasing in the region of 90 till 100, 110 degrees C. And with this, repetitive peaks are coming up, and you can see that even the medium pressure side is also increasing. When we stopped this compressor, this was the result when we looked at the actual bearing on the medium pressure side. You can see this typical brown light orange layer already affecting the temperature behavior. Another good case study was also bearing temperatures in a refinery.
Sorry,
Yes.
Jo, seems that some people actually is finding your slides stuck on the same position. Can you check as well? Maybe can you move again the slides? Because we can see only one slide now, case study overview, but it's not.
Oh, what is going on? Which case you have now? Which slide you have?
The introduction of the case study overview, so vibration A1.
Hola. That is, thank you very much. That is very strange.
And the slide 41, we were still at slide 41.
Are we now, what slide do you see now?
Wait a second, now case study 1, try to change, go down.
Yeah, I did go down. Do you see it?
Still case study 1, it didn't move, it didn't change. Maybe you have to close and open every time, because it seems that.
I apologize for this.
Yeah, if you do that, we can see.
Yeah, so I apologize. Here we show you the, thank you. So now you can see here I repeat the bearing temperatures.
Mine is still black. Mine is still black. It's still black, mine. I don't know if for the others it's the same, but I can see only black screen.
No.
All right,
No.
keep this one, and then we can see just it's better to maintain this one. Probably is not.
Okay.
Yeah. Yeah.
Okay. So this is the graph of when you don't flush. We see here the evolution of the bearing temperatures. Here at point 0, we have the new oil, and when we add it to the system, you can see that within 2 to 4 days there was a steep increase of bearing temperatures, and you can also see that on the medium low.
Sorry.
You need to change the slide.
Click on 45, Jo.
That's 45.
Yeah.
What do you see?
44.
There's something wrong here. Yeah, okay, well, we'll have to come to the conclusions then. So apparently there's something.
You want to close it again and open it again, all the presentation?
Just a moment. That's very unfortunate.
It's in Belgium, I told you. We should have done for the Netherlands.
What do you see now?
I can see black. You, Clive?
Screen.
Yeah, well, I don't know what to do. I think
Okay.
it's somewhere the software.
You can just make, I don't know, now I see.
I will start sharing again, just a moment. I'm started sharing again. What do you see?
Yes, okay, now, yes. Can you try to move up and down?
Yeah.
Yes.
Yes,
Yeah.
yes.
Yeah, there was a software error. I apologize. So, Yeah, this is the ratio between temperatures and, as I told you, the temperature behavior increase and also the vibration. Typically, you mentioned here the increase of vibration on this more rigid bearing. Flushing of oils, I repeat for the third time, so you may be bored when you hear that, but now you see the graph at least. Here we have point 0 where we added the new oil, and within you can see 3-4 days temperatures are increasing quite steep with this typical temperature peak behavior to above 100 degrees, and also for this medium low to high pressure side of the compressor. We opened the compressor and that's what we found on the radial bearings, these brown deposits. A good case study for you to show you the solubility effect is this gas compressor in a large refinery, measuring MPC before treating solubility. You see we have an MPC of 22. Automatically, when we treat with solubility enhancer, you can see this decom treatment. You are approaching MPC levels 1 to 3. For your information, 1 to 3 is the lowest level you can achieve with MPC technology for varnish analysis. Interesting from that graph also is that I come back to this graph you saw with this temperature behavior. Once you add the decon solubility enhancer, an immediate effect on the bearing temperature was noticed. Some small spikes appeared, and that's logic because it starts to dissolve, and also what's been deposed bring back in solution. And but automatically after that, you have a very nice stable layer of so proving a good deposit control. Bearing temperature spikes and the rotor repositioned in its normal position and bring MPC level to a very low level. Case 4 is a nitrogen compressor in a fertilizer plant. We here at this point the customer started up with a new oil. System was not really flushed 100%. And within, you can see within 6 days, we already had a high amount of spikes. We added here a solvency improver to bring it back, but more important, what we found out, the root cause here is that the cooler was not cleaned. In between the oil changes, they forgot to clean the cooler, and what we can recommend you also with gas turbines and steam turbines and compressors is when you do a revision and you are changing oil, do not forget to look at your cooler. It can build up a lot of varnish, and then with the new oil, it can dilute and solve again some of the varnish, again entrained to the bearings and building up these deposits. The last case study is the long-term effect you will see on bearing temperatures by treating solvency. And you will see that in the beginning here, it's very regular peaks till 120 degrees. Here we had 2 treatments of solvency, 1 treatment there to control, and the second treatment, and you see fully stabilization and solubilization of the deposits and also maintaining bearing temperatures. With, of course, afterwards the visual control, as you can see here, with totally clean axial, radial bearings, components cleaned and having no deposits. We see here again this nice effect on another fertilizer plant, also high bumps of peaks of bearings, 120, and as soon as the boost or the solubility enhancer is added, you can see here normal temperatures, and then after that the oil is changed. As you can see here, we stop. Another good stabilization case study. So we are over our time due to some software issues, but we come to the conclusions. Absolutely, we can say that varnish is underestimated today, and there is a direct link between the varnish and the cause of bearing temperature excursions. If you recognize a sawtooth temperature trend, like we've seen in these examples, make sure to look at your oil analysis, identify MPC, and go try to identify some root causes. We can control the oil quality, remove the varnish, and keep the oil system clean, and make your system really 100% again operational on short term as well on long term. The ESP technology, as well the solvency enhancement, because we know, as a general conclusion, your equipment is an asset, but also your lubricant is an asset. And if you both approach them in the same way, I think you will have an optimized reliability. I thank you for your attention, and I'm here now. If any questions, I will hear them. I will have a look at some of the questions, maybe.
Yes,
Yo.
I have one. I mean, we have several. I will start picking up from the beginning. And maybe, I mean, you explained, but I believe that we should make it more clear. What is the connection between the vibration and the temperature? So the question is, if how varnish affects the vibration test?
Oh, but I think because your oil layer is, you don't have the right hydrodynamic oil film anymore. It's oil film disrupture. It's not more than that that is happening. The thicker this oil varnished layer, you're sure you will have totally different lubrication conditions, and certainly the hydrodynamic regime is affected, resulting in vibration.
Yeah, I have a question connected to this. It's coming from myself. Can we say that temperature is always a precursor of the vibration, or can be the other way around? First the vibration, then temperature?
I cannot say that. I've seen only case studies today where temperature really is increasing and then showing vibration. That's really what I have seen today, yes. It can also be that you have misalignment, and then of course, then you will have already from the beginning vibration occurring, and so, but that's two phenomena, different phenomena.
Okay. Clive?
Any
Yes,
other
of course.
questions?
I've got a couple of questions for you, Jan. How effective is the cooling of the oil to remove varnish?
How effective is
cooling the lubrication oil to eventually remove varnish?
cooling? It will not help. Cooling will not help because cooling will only agglomerize more, and so it will create the solubility goes down, and if solubility goes down, you will have more deposits of formed insolubles, and then formed more layers of varnish. Think about your valves, your hydraulic valves, regulating valves. If you cool them down and you have varnish contamination, they will be sticking just because you've cooled down the oil. So it's not a solution. Absolutely not.
Okay.
One for you. I mean, this is. So what's happening? Why in the past we could not see varnishing, or at least almost zero varnishing 20, 30 years ago, and now with the new oil, it seems that is more and more common.
Yeah. So yes, that's a good question, and in fact, it could be a webinar on its own to cover that. So to be very short on that, I briefly touched the solubility changes in group 1 to group 2 and group 3 oils, even beyond group 3 oils. Think about GTL lubricants, which are today the state-of-the-art lubricants on the market. Well, if you look at the group 1 oil, it was an oil we used for 20, 30 years ago, and still some countries or applications. But group 2 and group 3 oils have a better base oil, more solid, more oxidative resistant to GTLs, really 100% oxidative stable. So But like with every, I would say, good side, a pro, there's always like some contra, and I think the negative, the downside from these strongly base oils is that your solubility goes down because you refine these oils, you remove all the aromatic constituents and components, and that brings down the solvency. So less solvency, then at the same time you're not able to really keep oxidation and degradation products in solution, and that's why we've seen starting in 2002, 2003, the first signs of varnish coming onto the market when the first transitions was done to group 2 and group 3 oils. So that's why you should not mix really oils, because solubility is totally different. Also, the reaction products are different in a group 1 versus a group 2, group 3 oil. And don't mix them. Make sure you flush. You don't leave remaining oxidation products by moving to a group 3 or group 2 or group 3 base oil. I hope it helps to answer your question in a nutshell.
Jo, a quick question regarding combined lubrication and seal oil systems. If we're cleaning up the system, would let's say the deposits that are being cleaned up and out of the system, would they have any negative effect on the mechanical seals? Would they create a leakage or issues with the mechanical seals?
Well, what the issue with those, what we have seen is that as the residence time of the oil is in these seals is longer, if you have oils which have a little bit too high amount of oxidation products, deposits, MTC if you want, due to the longer residence time, yes, you have a risk of them being, I would say, not really burned, but they stay longer in those seals and they create deposits. So we have seen it also on hydrogen seals having more deposits because these contaminations are staying too long at a too high temperature. And then, yes, it's clear that these contaminants, they do not like to stay too long at a too high temperature and will agglomerize and form these typically brown, black deposits on seals. Absolutely. So watch them. So keep your oil.
If we used a solubility enhancer in the system, would that have any negative effect on the seals, or would that?
No, because the lubricant it will only enhance. It will only enhance the solubility. Is not affecting any of the characteristics of the lubricant. All the basic characteristics of the lubricant are unaffected. We just increase solubility, so it will only be an enhancement, and certainly not have an effect on mechanical seals. We have now so many of these systems working with solubility enhancers, so no, absolutely not.
Okay. We have several questions, all regarding interaction with existing oil, with the product, with the solvent cell products. So if there is any interaction, or if can be any problem with existing oil. And just another question is about when you use this solvent cell, can you clog the filter and then you have to change them very often?
No. So second question, no, because we've never seen any issues with filters clogging, just for the simple reason, as I was showing in one of the slides, is that we dissolve the layers of the varnish slowly, layer by layer, and we keep the varnish or the contamination in solution, and then it's removed. It's staying in the oil in solvent, really by solvency. If you have an ESP, then you can even remove that if you want in addition. But no, it will not. It will not clog the filters. What the only thing you could possibly see is that you've seen in some hydraulic systems where you have more some wear metals and other components that maybe as they are sticking to the varnish, that they can be released and then maybe foul your filters. But in general, more than majority of the cases we've done, we've never seen an effect on the filter. So your first question was again, it was on mixing oils, eh? Was that the question?
Effect between a lubricant oil or the hydraulic oil with the solvent set?
No, it's just that the hydraulic oil, of course, you don't have the high amount of circulation. That is the only issue, is that you need to make sure the solvent has a chance to work. You don't have the same flow rates as you would have on the lube oil. So that's the only thing you have to watch if you want to make the solvent act and work. But in any case, it will work as well on hydraulics as on lubricants.
No, I believe it meant more like in terms of compatibility. So
no, there's no compatibility, no issues. No. Other question? I see.
Yes, a very simple one for you, Jo. What would you say that the difference is between sludge and varnish?
Oh, I would say varnish. Like I said, the definition is really it's mostly organic. It is like a polymerization, agglomerization process. It's sticking to the metal surface. You cannot remove it. Sludge is just all the opposite. Sludge, it's more agglomeration of consumed additives, some antioxidants, EP, reacting with water. Mostly it's found more on like, I would say, steam turbines, all the type of steam turbines, where you have had water accumulation and reacting with even some bacteria can form into the sludge. It's a clear different color also. Sludge is never really looking that orange brown color. It's a different layer really. It's more attached to the metal surface than a sludge is really an agglomeration. Very, very, very different, I would say. And the best thing is always to run oil analysis. I think if you see you want to have certitude, run your MPC, run your ruler, run some of your air release and foaming, and if you varnish, all of these parameters will give you a good indication. With sludge, mostly not. MPC will not be affected by that, neither foaming. So yes, that is the difference.
Okay, I've got one other one, which is something that I think that we at Fluitec are hearing more and more often now. That a customer is using one of our filter systems, ESP systems, and if he stops using it, he's noticing that his filters are starting to block, but he's not necessarily seeing a rapid rise in rapid rise in MPC. His MPC is remaining low, but he's getting blocked filters.
Yeah, typical. Yeah, very, very good case. I was also last week, not last week, the week before, because I'm stuck at home. So, but yes, typically a very good indicator of the very premature signs of degradation is what you see there. If you see that if you treated ESP and then you still after that you bring it out of service and your delta P starts to increase again, it's this very small, I would say soluble amount of degradation products created by gas contamination. We've seen it on nitric acid plants, for example, typically occurring also with the HCl gas compressors, ammonia compressors also. It's very, very small, fine varnish present, and even in the lower levels, not even detected by MPC. So if that is occurring, you look at your particle size counting as well. It will give you most indication that you're building up these first stages of soluble varnish.
Okay, and this technology, so I believe we talk about ESP, may help to separate water content in the oil?
What is it? Sorry, can
no, you get some water content in the oil. May our ESP technology helps to separate it?
No, No, ESP is not made to separate water. If you need water, if you have water, which today it's for us very very uncommon these days today. I think you need to use like a vacuum dehydrator or yeah, mostly vacuum dehydrator to remove successfully your water. That is a totally different phenomena. But water, then you need to watch afterwards your MPC because the water accelerates oxidation, creates a depletion of antioxidants, and depending from the type of oil, the consumed antioxidants with reaction products, because you create oxidation, can then form a varnish. So yes, watch them both. First, remove your water, make sure the water is removed, and then a second stage, closely monitor your MPC, and you will have probably most high chance to remove the varnish. Absolutely.
Okay, I believe that it's 2 o'clock. We need probably to call it. I don't know. Do you want to provide maybe your, if anyone has other question, how can they contact us?
They can contact us always at info@fluitec.com or j.ameye@fluitec.com. But info@fluitec.com via the website. You will find us anywhere, all over the world. We are present and we are going to repeat these webinars as we all have time. So I would like to thank everybody for his attention. I found it hopefully for you also as productive as it was for us. I see here, yes, 2:05. I apologize for the little software bug we had here, but it was out of our force. I wish you all good health and stay safe. And I would say for those who are in countries where we are in contingency, stay inside. That's the best you can do, and that's why we organize this webinar. So thank you very much, and we will stop now this. Thank you very much.
Thank you. Thank you.